Right, good morning. I'm on a lav, if you can make that one live. So hi, my name's Will Law from Akamai, and surprise, surprise, I'm going to talk on CMCD. I've told people it's the last time I'm talking on CMCD because this time we've finally finished the spec. We finished it just 2 weeks ago, just in time for the conference. And in fact, we changed. We made some last-minute changes there, so, all for the good. So I'm going to bring you some very fresh information, and hopefully at this point the specification's done and we can go forward into the future. I actually want to start where many other presentations might finish, which is with a thank you slide. So this has not been the work of one people, it's been the work of a whole number of people. And I'd say half of these people are actually in the room today. So as a chair, I want to thank you. It's been a 3-year project to do the revision 2 of CMCD. And even over the last year, we've been meeting every single week, which is a high cadence when people have jobs. And I ranked people by the number of meetings they've attended. So Nicholas Levy won for perfect attendance for 34 weeks in a row. So congrats to him. Anyway, if you see these people in the corridor, thank them. It's been a lot of work. As I mentioned, there's been a number of talks. I want to show you how CMCD has evolved over the last 3 years. If we look here on the left-hand side, this was a talk I gave at Demuxt back in 2024. And we had 3 modes that we were using, and we had query args and headers as the transmission modes under each reporting mode. If we go to Nicholas's talk at Demuxt 2025, we can notice that the JSON batch has been taken away. I show the change in yellow down there. We substituted it for a post batch, which is a simplification. And then we had the realization that response mode is just another event, right? So we invented a new reporting mode called event mode, and we were able to get rid of response mode. And today, just from 2 weeks ago, we've got rid of query args and headers in the event mode, and now we purely use a post, both for single and batching on the reporting side. So you can see an evolution. As we've been working on the spec, it has become cleaner and more precise with less variability in how things happen. In this talk, I've said it's a diff, right? So I want to show what's the difference between V1, that is deployed in many production systems today, and V2. So here's my convention. The dark stuff on the left-hand side is V1, and the clearer stuff is V2. And I don't have to keep repeating that. It should be obvious to you what's there. So let's go. In V1, we had no batch mode. We only reported data when you requested an object, so it didn't make sense to back it up. We did have a JSON mode, which theoretically could have been used for batching, but it was never defined for that. You could only report one thing at a time. Now, in V2, we have a batch mode, and it's also the mode that can report a single item. So it's a post. The content type is text/CMCD. It's basically test. And it's done without URL encoding the content because it's in the post body, right? So here's an example of a single report. And if I want to batch it, I simply put a line feed character, and I append my second report, and another line feed, and I append my third. So it's very simple to parse it. It's human readable. I can understand it. It's not URL encoded. I think it's a nice improvement in how we can post to third-party systems, which is a big feature of CMCDv2. So reporting modes. In V1, we had one mode, right? The player asks for things, and when it asks for things, it appends either query args or headers to that, and that's the structured data that CMCD defines. In V2, we continue to support that. It's like a legacy mode. You can carry on using it in exactly the same way, nothing breaks. But now we add the ability to report data out to a multiplicity of third-party sites. It's done via HTTP post. So as the player is requesting objects, it can send other reports to other locations. And in fact, it doesn't need to report it to the CDN anymore. The CDN was a bit of a bottleneck. You had to collect all your CDN logs and pull out your CMCD data. Now you can get the raw, concise CMCD data independent of the CDN logs. So when do we send it out to these third-party sites? It's all based on events, right? An event triggers the sending of the data. I'm not going to read everyone here. You can do that. But the major groups are user interaction in the player, playback changes in the player, advertising, which is a very interesting. We've had 3 talks now with ad, but you can start to use CMCD by design to start reporting playback of advertising content, and then others. So just a couple of things to point out. On the play state change, we now support detailed playback states of your player, and we can report any one of these at any time, and I'll show a demo of this later on. The response received is the simplification that says, hey, when I'm requesting an object from my CDN, and I get data back from it, I want to report that fact to some central monitoring service. And this is very useful if you're using multiple CDNs. I can report all of that back to one central data collector. And custom events. You can define your own event in the player that's maybe very particular to your player. So you have an online poll, and you want to track that somebody has voted in that poll. You can do that. You don't have to come to us and say, why didn't you put this special event that I care about in the player? You can add a custom event yourself. And then time interval is the basic one. Many of us just want to build monitoring systems that monitor 10,000 live players, right? We certainly don't want the details of all of their play state changes. We just want to know what their buffer lengths and how many are rebuffering. And you can get a report every 30 seconds if you want. So some keys have changed if you're using them. The bitrate key, if you remember in the past, was bitrate, and that I had to send an object type to tell you what I was fetching. Is it a video segment or an audio segment? But now with events, we discovered, in fact, inner lists with structured field values, which makes it much more concise. So now we declare bitrate, and I can say, hey, I've got a bitrate of 3,000 kilobits per second for video and 64 kilobits per second for audio. And I can put it in a single report. And this feature for bitrate, we can extend to buffer length, top bitrate, measured throughput. So all the stats you see on the left-hand side, which are pretty verbose and could only occur one at a time on a request, now we can put them in inner lists. So when I report buffer length, I can report it for both my video and my audio buffers, also my top bitrate, and my measured throughput, if I'm measuring different throughput when requesting different objects. So a lot more concise, a lot cleaner as we go into the reporting. Some keys have changed their definition. So in the past, we had next object request and next range request. This allowed the player to pre-fetch content. You can hint to the CDN what's the next object you want, and it'll go pull it to the edge for you. But it was constrained in two ways, right? You can only fetch a single object, and you had to use a separate key for the range. So now we've improved it. We've kept NOR, but NOR now, we use an attribute, which is the range, and we simply say, I want you to fetch video 01.mp4, and by the way, you should fetch bytes 0 to 558. More importantly, we can now hint that multiple objects should be prefetched. So if you're starting up an HLS session, for example, even a -1, I want a video object, an audio object, and I want the inits for both of them. So now we can do that. It's just a list, right? I just send the list of files that I want. They have to be relative. They can't be external URLs for safety, but we're able to expand and improve upon the prefetching that we can do with CMCD. Some keys have also changed their definition. Stream type, right? So stream type, we added on live low latency. This was keeping Alex Galati happy, so amongst others, so we can have it on. Streaming format SF, we added in HESP. This was to keep JP happy, so we're trying to keep a lot of people happy in the industry here. Someone else needed longer content ID, so we can track content. So that's longer. And version now, because keys have changed their definition between V1 and V2, when you use V2, you must put V equals 2. You have to communicate the version from now on. And we have some new keys. So those were the ones that have changed from the old. Now we look at some of the more interesting ones. The first one is this notion of an event, right? It's something that happened, and I'm sending it along. So here we have a time event. Anytime you do an event-based report, you have to tell the collecting system what event triggered it. Here it's a time-based heartbeat. And because we want to sequence these results when we receive them, you also put a timestamp. So in the second one, we see, oh, I got 2 events coming on, and I get the timestamp in milliseconds of when the event was triggered. And this allows your receiving system to order them on a pipeline, even if the posts come out of band. And this came from Pierce, actually. What if I'm a collection system, and I get these timestamps, but if there's gaps missing, I don't know if the player didn't send them or I've lost them, right? So now we put in a sequence number. So you can see in the bottom, the analytics system got 634 and 636. It can infer that it's missing 635. There's some missing data there. So a simple little counter, but it adds a fair bit of utility and robustness to the collection of the data. We have a new key called state. So as I mentioned earlier, we can track play state now. And there's a lot of literature and academia on what's the whole variety of play states players can be in, right? But we defined some major ones: starting, playing, rebuffering, seeking, fatal error, quit, preloading, etc. And now, here's a typical sequence. My player is going to start, and then it enters a play mode. When it enters P, you notice it's reporting MSD, which is the media start time. So now we can explicitly report the time your player took to start. Then it rebuffered, it recovered, and then the user quitted at the end. So a typical sequence that can now be tracked with CMCDv2. Playhead time is also the current playhead position in milliseconds. There's a lot of features, something that was absent in V1. We chose milliseconds. It gives you frame accuracy even at 60 FPS. It's sufficient. People wanted microseconds, but we thought it was too verbose for what we're trying to do in CMCD, which is the philosophy of reporting from the end user's perspective, what's happening in the player. And also error codes. So we have the ability to play back a string, which is an error code, and we really encourage people to look at SVTA's Common Player Error Codes project, which is trying to harmonize all the thousands of different error codes across players into a consistent set of numerically reportable error codes. But we do support those. Even though they're numbers, they'll be placed into our standard as a string. And we have a number of ways to report bitrate. It's improved as well. So if I have a typical player, I've loaded some content, I got 3 meg, and then I switched up to 8 meg, and we're observing this at now is our rendering head, right? We have a key, which is the playhead bitrate, which is the bitrate you're actually rendering at the moment. And then the encoded bitrate is the bitrate that's being loaded, right? And you might have 2 minutes worth of buffer in your player, so these can be quite different numbers at the end of the day. And then for media playlists which provide bitrate info, we found out with V1 that if people said, oh, my player's playing 2 meg stream, is that at the top or bottom of its available stack? You don't really know, right? So now we can report what's the top of your stack, what's the bottom of your stack. And when I'm monitoring a whole set of different players with different ranges in their bit rates, I know where the players are, right? I can do a percentile of the top bit rate, and I can normalize them across different players. And then for HLS playlists, which only provide aggregate data, they don't give you the particular data of individual track. Now we, again, similar feature, the lowest aggregate package, the top aggregate, and the one that I'm actually rendering. So we do have good support for HLS. In fact, we had good participation from Apple in V2, which was a nice improvement over V1, where we were trying to guess it from the outside. So a lot more new keys and performance. I'm not going to read out for metrics, just to highlight a couple of them. Media start delay, I mentioned we can explicitly track the start time now. It's only reported once, but that's another common feature that we want to know for QoE metrics. We have lots of ways to count buffer starvation, which is basically rebuffering. We can count the number of times you rebuffered. We can count the duration of your rebuffer events, because if I have 3 that are 50 milliseconds each, it's not as significant as 3 that are 3,000 milliseconds each. And also, we report both absolute and relative values for rebuffering. The difference being that if I just want a reporting system that throws up a flag whenever a cohort of players is rebuffering, I don't want the absolute value, right? Because it might have rebuffered in the first second and never again. So there were use cases for both relative and absolute, and we decided to incorporate both. And target buffer length. This text is hard to read. Useful for normalizing and comparing buffers across different players. Yes, another problem. So my player has a 6-second buffer, right? Is that good or bad? So if my player is meant to have a 30-second buffer and it's got a 6-second, it's bad. But if my player is meant to have a 5-second buffer and it's got a 6-second buffer, it's good. So we didn't know. It's hard to tell, again, when you're monitoring across players. So by putting in the target buffer length, you know what percentage buffer fill you have, and that's a much more useful metric for monitoring the health of your players. There are some new client processing rules. In V1, we were very airy-fairy about how players should do it, and then we decided to tighten that down a bit. So we do encourage players to develop config files that tell you which of these events you should be reporting. And we now have sample config files. -JS is leading in this, and you can copy its config file if you want it. We don't recommend that all keys are sent all the time. There's now too many of them. We also meant a back-off strategy. When you're reporting all this post data to a service, we now have some behavior that we want to see when you get non-200 responses, or non-204s, actually. And also, we encourage you strongly, in fact, it's a normative must, that if you are reporting session ID and content ID, you must keep them consistent across all modes, right? So that your analytics system can use them as keys to join the data. So as I mentioned, we don't recommend all the keys all the time, even though there's lots of them. And session ID allows sequencing and joining of data sets. We do have some network and response codes. These were not possible in version 1 because you're making a request for data. You don't know what the response code is going to be when you make the request. But now, when we can report it based on the response received, we can go time to first byte, time to last byte, URL, etc. And here's a typical response. All the ones in yellow are data that we could not report in V1 that we can report in V2. And this is, if you wanted to send everything, this is what it would look like. And just be careful, some of the keys have a lot of data. The ones are highlighted in orange here, session ID, CMSD, we can now reflect it up, and streaming media request tracing, which is another CTA spec. Be careful of those, they will bloat your reporting. Just, so, 3 more slides left, basically. Use case, investigating H3 priorities. Very interesting project that Alex, Pierce, and Nicholas did. Normally, you would have had to build a special test harness, but now you can just use CMCDv2, collect the detailed data, and you should ask them about the results. They got some very interesting results. I'm just showing you one slide of it here, not for me to reveal. And I then, the video's playing. So to show it working, I have a version of Dash.js, which has an implementation of CMCDv2 from just 2 weeks ago. On the right-hand side, I've built myself a little data collection service. You can see in the green line, it's tracking the buffer, and the play is just loaded. Dash.js will preload at start. Then I hit play. So now I'm starting to track the green line is my buffer, and the bottom line is my audio and video bitrate at the bottom. And the vertical lines is my play state. Right, so it's playing, and I'm getting a report every 5 seconds. I just told it to pause, so that's the red lines, and they're reflected in the data. And now I will resume again. You'll see the buffer should continue. It held its buffer. And after this, I'll do a seek. So as we seek forward, we'll also get a report on the play state change, and then you'll watch my buffer build in the background. So this is the type of reporting you're used to do in a lab. There's nothing new about this. What's different about this is we can do that across hundreds of thousands of players if we want to in individual sessions. And it's a standard reporting behavior that will be built in to every player, and we can just avail ourselves of it. So more of that later. Common Media Library, SVTA is doing a lot of work to normalize this. That is Casey at the computer along with Nicholas. They're making it very, very simple to use CMCDv2 and to support this event mode and the request mode. So Nicholas is giving a tutorial on Wednesday at this conference. So if you want to see it working, ask him detailed questions. Go and watch that session. And just a call to action for the room. We do have some initial player support. HLS.js, Shaka, basically players ingesting Common Media Library, open source. But now we need the players. Most players support V1 already, but for V2 we need AV Player, Video.js, BitMoving, Exoplayer, or Media 3, Mux, Smart TVs. So the work shall begin. And thank you very much. Apologizing for going over time.
Thanks, Will. You are still unstoppable as usual. Yeah. So quick question for me. Is CMCDv2 ready for MOQ, or do we have additional work specific to MOQ to bring to the spec?
No, I believe it's ready for MOQ. In fact, I gave a demo of it being used with MOQ at Demuxed 2 years ago. Wow. Yeah, so the fact that we can decouple it from requesting objects means we can use it for generic player behavior. And a player that's using MOQ still has a buffer length, it still has a play state, it still has many of the attributes. There's no reason why we can't use it for that.
Thanks. Another quick question to finish, or are we good for the... Thomas? Yeah.
Great. This is a little off topic, but what clear business advantage have we seen from CMCD now that it's been out there for a couple of years? Just in summary.
So I work for a CDN, so for us it's been able, the fact that now cohorts of players can tell us when they're having problems as an early warning sign that we're doing a poor job with delivery has been a huge change for us. But we have a lot of customers who are using it for data collection, right? It used to be a complicated process, and you had to go install a client analytics module in your player in order to get data back. And now you can have a built-in behavior that will send you data and you can collect it. So people, we're not changing the need to analyze, we're just giving a simple and direct and effective path to doing that. So I think its adoption has been dramatic over the last 2 or 3 years, and it's taken as a de facto now, and I hope that CMCDv2 actually extends its utility even further.
Thanks, Will.
Thank you.